Hi guys, this is Abdurrahman Gilal once again, and I welcome you all. In this short video, I'll be trying to explain you relational and logical operators. And why do we learn this? This is very important because, as per basic understanding of computer, that like a computer has always a CPU as the main point where we work. How to say we process every kind of computation. So in this central processing unit, usually I describe this way to my students that we have CU, means control unit, and ALU, which is arithmetic and logic unit. So its control unit connects to the memory and connects to the components of the system, so that it provides some computation data or processing information towards or onwards to processor. So basically arithmetic operations, we know that we've been learning that we have this plus, minus, multiplication, division, or etc, right? So the another unit of computer that is actually the unit where we perform some logics. So in order to do the logics, for example, we need to learn this topic. So we know that computer does logical operation as well, which is what making computers different from calculators, because calculators can perform these operations like arithmetic operations, but computer does more than arithmetic operations. So that's why we have ALU in the computer central processing unit. That's relational and logical operations. So the relational, sorry, and logical operators are supposed to be there so that we perform relational or logical operations, right? So we have learned about this since our Montessori schoolings, that is how to do additions and how to do subtractions. This appears for us to be easy to understand, but when we go for the making decisions, there we have to apply some human knowledge. So the one thing is very clear, that whatever operations we perform here using these operators, for example relational or logical, the output will either be 1 or 0, true or false. So that's what we have to remember. So anything that we do here is not going to be, for instance, 2 plus 2 is equals to 4. We may have some computation coming into numerics, but here, that anything we perform in relational or logical operators, the output will be in Boolean, which is true or false. So how we actually design or write a program that makes it logical, not only computational like calculator. So that's why we have to learn that. And in order to apply those operations, this topic is very important. I'll be quick to explain first the theoretical understanding of this, and then I'll be explaining you then how to implement that using Java language. So we know that we have certain operators, and most of them has having said like we have understood, but we are here going to somehow learn a little more about them. So let me just quickly give you a recap of what we have learned so far in maths or in any other kind of classes, that we have equal operators, where this one basically helps us to assign the value to certain variables. So this appears same in the maths or in computer programming. For example, if I'm going to say c equals to 5, so basically 5 is going to be stored in this variable. But in mathematics, it appears okay. But in programming, we have to define that what type of variable the c is. So I said integer, so it can only store integer value. So this is called equals to operator or assignment operator. That's the same thing, right? Then we have heard of this minus, plus, multiplication, division, and modulus. They are the operators. They perform some arithmetic operations, right? So for instance, we have learned that c is equals to 2 plus 3. Now it will become 4. But that's also possible that we have some variables such as integer a equals to 5 and integer b equals to 3, for example. So I say c equals to a plus b. So what happens is then it goes to the memory of A and brings the 3, and then goes to the memory of B, then brings the 3. So 5 plus 3 is equals to 8. So now 8 is logically like this. This is how the value will be of the 8, because that is being performed on certain variables. And we have certain unary operators such as minus minus or plus plus, so which means that we have to do the pre-increment or post-increments. If I have a variable such as integer a equals to 1, and I say plus plus a, so it makes it 2. And if I say that a minus minus, so it basically reduces it to 0 because it reduces 1 only. So it's same in the mathematics, but just a little difference is that, for example, if we are working in programming language, if I say plus plus a, so it prints the value of a first, then do the increment. That's what we call pre-increment. And if I say a plus plus, so oh, sorry, this is called pre-increment, which means this increase the first and then print. So it prints 2, for instance. But if I say a plus plus, so it prints basically the value of a and then does the increment. Same goes with the decremental operator, that is minus minus. So these are called unary. Why do we call them unary? I hope you know that unary operators are those operators which basically work with one operand. So what is operand? Operand is like so anything that is basically coming to the left or right side of the operator. For example, I have 2 plus 2, so this is operand, this is operand, and this is operator. So if I have a plus b, so this is operand and this is operand. This is how it works. So the unary operators are those where we have only one operand. So it could be plus a, plus a, or a minus minus, or anything, because we have only one operator. So it's the same thing if I do like this way. It's a shorthand, but if I do like this, a equals to a plus 1, so it's going to be the same. So it's just a shorthand to do the increment. So I hope it makes some sense. So let's go further and see what other logical operators available. So these operators are sometimes called like comparison operators as well, especially the relational operators. So these are certain relational operators which make some sense that in maths we say this equal, but in Java this is not equal to. In order to do the equal to, we have to use this. So in maths we don't have any comparison, we have assignment, but in programming we have comparison, especially when we are working with logical operations of the program. So one thing one should be clear, that if the equals to appears once, it means assignment operator, but if equals to appear twice, it is the comparison or equals to operator. So this one is called assignment operator, and this one is called logical operator. So, oh, sorry, relational operator. So I hope it makes some sense. And then let's say that if you wanted to see this other way around, so we have this as a not equals to. In mathematics, we simply say like that, but here we say exclamation operator and then equals to sign. That this makes it not equals to, which means that the left hand side is not equal to the right hand side. And with equal operator, with this like Java Notion, we say left operand is the same as a right operand, so it makes to be like this way. And on the greater operator, this says that the left hand side is greater than the right hand side. This is how we can say, like for example, 3 is greater than 2. So this makes some sense. So that's pretty straightforward, as we have done in the mathematics. And here, like usually in math, we say like greater than equals to this way, but in programming, we say greater than or equals to, like very straightforward, greater than, and then equal sign. So it says that left operand is either equals to the right hand side or greater than. So it has not to be less than. So let's say if I say 3 greater than or equals to 3, so it makes sense. Yeah, that's as I said, we're gonna return us the value as 1, because 3 is not greater than 3, but 3 is equals to 3. We're gonna get 1, which means true in simple words. So when we work on Java, you're gonna see we're gonna have this as output as true. So this is the same thing for the less than or less than equals to. I hope it makes some sense. For example, 2 is less than or equals to 2. So yes, 2 is not less than 2, but 2 is equals to 2. So that's true. But if I say 2 is less than or equals to 3, so 2 less than 3? Yes, that's true. If I say 2 less than or equals to 1, is 2 less than 1? No. Is 2 equals to 1? No. So it goes as a false. So I hope it makes some sense. It's not like arithmetic operations where we directly get plus or the numeric values. Here we get the Boolean values, which means that either the answer should be true or false. So, okay, so let's go further and see what theoretical content available from Walter Savage. So Walter Savage says in order to do the logical operations, we need to use logical operators. So most of the time, what we do is that we use logical operators alongside with the relational operator. So what does it mean? That you have done some computation with relational operators, but at the same time you wanted to make sure that you have more than one type of conditions to compare. So there you should be using logical operators. So logical operators are basically three. It has to be understood that are AND operator. Give me a second, sorry about that. Yep. So we have this AND operator, which is logical and this is called logical OR, and this is called NOT, which is the unary operator once again. So it is called negation. Sometimes it converts the value from 1 to 0 or 0 to 1. So we understand like this. For example, if I say 3 is greater than or equals to 3, so the output should be true, right? But if I have applied this explanation, so it will turn it to the false. So if we have a true, it will convert it to the false, or false, it will convert into the true. So it will become now false. So it is once again unary, which means that you have to provide only one side. So it is not possible that I give like this, which is if I do like this, so logically it will be basically converting the true into false. But if you try to do like this, so it's not gonna work anyhow because it does not work with the numeric. So we may have some errors, found in the program. So let's see that AND operator says both side should be true, then only it will return us the output as true. If any of the side that is false, the overall output will be false. So it is a very easy truth table that we always make. So false, false, false will be returning as false. If we have false and true, it will also return as false. If we have true in any side and then we have false, so this will also return as false. But if we have true at both sides, this is AND operator, I'm sorry, like this I'm saying, so it will return us the true. So this is only possible when both sides are, or both operands I would say, are true. For example, in real time, your username plus password should be true. Like if someone is trying to insert the username correctly but the password is wrong, so this whole logical operator will help you to justify the both of situation. This happens in our regular, life experiences. So we have also this like OR operator. OR operator says any of the condition is true, has to be true. So let's say we have this relational operator, answer is equals to y, or answer is equals to y. So someone is trying to write in the small case or the uppercase. So this is the relational operator, but this is the logical operator. So how it happens? So this has to be if only both of them are false, then only the output will be false. Any of them is true, that is going to be true. That's how we have to read. So it's like this. So if any side is true, we consider true. Both sides are true. That's in fact awesome because we have true. So we have AND operator, we have OR operator, and we have NOT operator. So these are the three operators that goes into the condition of logical operation. And we have, give me a second, let's clear all the drawing. Yeah. And if we have relational operators, so we have basically 6 relational operator equals to, not equals to, greater than equals to, less than or less than equals to. Here they work on 2 operands. They also work on 2 different conditions. So that's slight differences. Here we have to give two different how to say two different operations. It is also possible that you can understand. I'm going to show you like what if I write this way, that for instance if I write like this, that 2, and I write this AND operator and I write 3. So what will be the output? These are not the relational operators output, but what should be we expecting? So you're gonna see like so because 2 is something to be considered either true or false in Boolean, because they work only on Booleans. We will be looking at when I code it. I hope I will explain it and then you will understand better that this is not a Boolean. So 2 and 3. So basically here we should be using some relational operator instead of the logical operators. But what output will come? This is certainly going to be a slightly logical problem, but program will run somehow. I will show you like how it will work when I come on the side of developing it. So yeah, so we understood it, and then definitely this is the truth table that we just discussed. I hope that you will experience it and will see that. So how do we work over them? It's simple is that we write the code in simple way that we have variables or any constants. So you can work on anything, variable or constants. You can just give, and then you can use them all together, or you can use with the logical operators such as and or not. So what will happen, for example, let's say a is, for example, give me a second. So let's say a equals to 5 and make the b equals to 3. So here we have the same thing that we have a is 5 or b, which is, sorry, give me a second. Yeah. So 3, and then we have and operator, and then we have not, and then we have uh, 5 and 3. So how the output will come. So that's what we have to understand, that usually like if it's true, surely it's true, and then this will become true, and then it has to actually convert it to the false. So let's say I'm just trying to so output will be, let's say, true. So we will see like how it works later on when you start doing the coding. I hope it makes some sense right at the moment. Okay, so let's see like what Walter Savage says. So of course, when you apply the negation operator or not operator, it basically changed the condition. For example, less than. So if you apply not, it converts it to greater than or equals to. So it means that the value which is smaller than the left hand side will basically has to be the greater or equals to the right hand side. This is how it just changes. So it's just a logical thing. Either you use this one or you use that one, it's gonna be the same. Output will be the same. But definitely if you apply the not operator. So if you apply not operator with this relational operator, less than or greater than or something, it will definitely change it to, for example, if I say uh, it is equals to some something, and then you apply not. So what does it mean? It means it's not equals to. So it's, let me just quickly give you an example, which I hope it makes some sense. Let's say if I have a is equals to 5, the same thing, b is equals to 3, and both of them are integer. So I say a is not equals to b. So what I'm saying here, 5 is not equals to 3. So in your opinion, it should be true or false? Definitely it's true because 5 is not equals to 3. So the output should be true. So if you apply the not in front, so what will happen? So it will convert it into the false. So why does it do that? It says that you have this not equals to will be converted later on to equals to. So now it means this 5 is equals to 3. So that's not true because you applied not. So sometimes we have a conditions where we say the password is never empty, or the username does not have any special characters. So when a user put the special character, so you have to negate, right? So you apply this condition. Okay, so let's quickly go further, see how theoretical it appears. Okay, so that's okay. I hope I explained this as well. So you have if statement, which I'll explain in my next video because we are not discussing about this controller structures yet. We are discussing just simple, logical operators or relational operators. So only a thing that is left is the precedence, like how we basically see which one has the highest precedence, because previously we understood only two types of precedences, like arithmetics or unary. So in this in this video, we understood two different operators. So first thing is very important is that all the unary operators. So this plus does not mean that we are trying to talk about the addition. This is the plus of unary operator. So as we say, like sign number -5. So this is just a single number. So if I have an integer and if I assign -5, so this becomes a singular, right? So this is the unary operator, right? So it's a sign or unsigned, it's increment or decrement or not operator, right? That's how it works. These are the top priorities. And so this is like always will be solved before these two, which is and or are. So it will change the overall output if we don't understand the precedences. And then second precedences will be given to multiplication, division, and modulus. And third is plus and minus. And the fourth is the logical operators. And the fifth is this logical operator, which are equals to not equals to. And then you have Boolean operator such as and, or such as a Boolean operator this or, but one, or this. So I hope these two we have not discussed yet, but let's say we have discussed all of them. So let's try to run it and see like how it appears in the program. Let me just quickly open the program. Give me a second. Okay, so yeah, there is the program that I have just simply written. Oh, sorry, the class which I have make like relational and logical operators. So just for my own understanding that how it works. So the first important thing here, we have to understand that we are using relational operators for the comparison and logical operator for the decision. Or sometimes we combine them, logical and comparison, or sorry, relational, to make the big decisions. So they work all together. That's how we have to understand. So their output can be still used in further. We can use it the if statements or switch statements. We'll discuss them later, but right now we just understand that these are the operators that are helpful for us to make some decisions. So let's just make it public static and void and main, and then we simply say, give me a second. Yeah, yeah. Okay, so sorry. ARGS, that's how we write. And then let's start from the variables such as I just simply told you, that we have two variables such as integer a and integer b, and then I assign the same values. And let's make it integer c as well. So assign some values such as let's 20 or 30, whatever. So first of all, SOUT, as whenever I SOUT and press tab, it basically shows me this println automatically. So let me write as a is equals to b. Is it true that a is equals to b? So let's see what output comes here. I say a equals to b. So as per my understanding, I'm saying that this is not the assignment operator, but it's a logical operator. Oh, sorry, relational operator. Let's run it and see what output comes. So that's false. That's not true. If I say a is not equals to true, let me just copy it and run it. And now I say a is not equals to. I hope is not equals to. So let's run it and see. So yes, A is not equals to B, which is true, and that's how it comes out. But so like this has to be understood here, that we are trying to compare this side to that side. This is how we come. But when I say equals to or not equals to, both of them can be used. But let's say now we are gonna say like A is greater than B. Let me say A is greater than B, greater than B. So I have to use this operator. A is greater than B. So now left hand side has to be compared with the right hand side. Here, this is just a description to be displayed, but this one has to be understood. The left hand side has to be, you cannot say like B is greater than A. No. So if I say B is less than A, that makes some sense. So this way I can write, because you have to, negate the operator here. But in general, we say A is greater than B, right? So let's run it and see. So it's true because A is 5 and B is 3. So is it possible that I try to save here this? So it's not necessary that we just only display, but we also can save this. So let's say in order to not just use the C, can I use like this? A is greater than B. Can I use this? So the answer is no. Why? Because C is integer, and this is going to return you a Boolean results. So either true or false. So you're going to see like you have Boolean, which has to be stored in the Boolean. So how you can change it in order to use the Boolean, you can simply write Boolean, which is very good. And then you can store it here, and then you can print Boolean here, and then you can run here. So the same thing is going to happen. You're gonna get it like true. So I hope it makes some sense. All right. So the same thing goes here. So it depends. Either you directly print, or you directly use it in some other operations, such as you're working with if statements or loopings or something that we'll learn later on. So we can do that. So only a thing that I wanted to discuss with you was, okay, let me just quickly go and say like, here I just use this A is less than less than B. So you should remember also that if you try to use this type of things, this is also going to create, because A is integer and C is Boolean. So you cannot do that. That's how have to be, both of them has to be either of different types, but has the same standard, such as I can compare the Boolean, also integer with float or double, but I cannot compare Boolean with integer or float because those are numeric variables and these are relational variables. So I hope it makes some sense. So let's say A is less than B. So let's run it and see. That's gonna be false. Yes, of course, one is true, so other is false. So let's now work on let's say logical operators. So the first thing we have to just simply say, like, can I just simply say like this, that A, let's say A and AND operator B. So can I do any operation right here? Let's just simply see first, and then you will understand better that it's gonna create some issue here. So there will be some programming languages, for instance, where you can use the operand where you have two or three. Can I use like this, for example, two or three, let's say? So maybe there is some way by which you can get it true, but it's not gonna work this way. So what you have to have either true or false. So you're gonna give me a true or false. So can we use directly true or false like this way? Or I can just write like true and then false. So it depends, like if you're working on different programming languages, gonna make sense. So let's say this is going to be false. Why? Because A is, oh sorry, true is not equals to false. So a logical operator says then both have to be the exact same. So that's how you have to simply understand both of them. So if you try to work on let's say third variable, let me just quickly change this. I am Instead of doing this, I'm gonna change, no, I better create a variable integers Z, and then I'm just assigning it 30. So now I know that Z is 30, right? So here I'm gonna say, like, I'm gonna use AND operator. So the first thing is, like, I'm trying to say like A is greater than B first. A is greater than B, and A is also greater than C. So sorry, Z. So basically here I'm gonna claim two different relational operations. One is A is greater than B, and I'm gonna say A is greater than Z as well. So this is perfectly fine in terms of operation, because this is going to be precedently first because we have used parentheses, and this is going to be second. And so this will return as true and this will return as false. So we know that in logical operations, in AND operator, you have to have both of them true. So let's run it and see. So this one says true, which is, yeah, of course, I have said A is less than. So if I do it like that way, because that was my fault, so it's gonna be false. That's perfectly true. We know that. So how about the same thing, but I'm gonna use OR operator. So here I can use this as well, because usually sometimes people, when they work on different types of theoretical explanations, so they can use capital N or capital R in order to just explain people that we are expecting AND operator here. So the same equation here, but I'm gonna make this OR operator. So when you have this backslash, so if you press shift and you click on backslash in any keyboard, it will give you this OR operator. So I just give you this backslash operator, backslash, anywhere you see, for example, this on your keyboard, this one, and you have to shift plus backslash, so it will give you one time this OR operator, and then you can make it like complete OR operator. Sorry about that. So just to make you understand, and then definitely we can either apply not here or above all. So I know that this is true, but this is false. So this will basically give us as a true, because one is true, anything is true. We have to remember that. So let's gonna see like yeah, I'm gonna say here, now I'm gonna just change everything to not. I'm gonna say not. So what is going to happen? So if I just convert it not, just one. So first one is not. So I know that this is the only one that is true, and this is already false. So the true will be converted to the false. So overall operation results will be false. So I should say nothing here. Yeah, that's okay. So let's run it and then see what comes. So the answer is false. I hope it makes some sense. So in the next video, I'll be explaining you then how can we use all of them together to make some decisions. So right now we just get either it's true or false. So something is true. So what should I do based on true? For example, username and password is true. So what should I do? Should I log in or should I not log in? So how you gonna do that? So stay tuned. Hope to see you soon again. Take care. Bye bye.